All right, can you see the screen?
Yes.
Yes.
Okay. All right, so we are using the same data. Okay, so just import the data. Have you been able to do so? Hello.
Hello.
Have you imported the data? Uh, if there's no noise at your end, please don't mute yourself. The thing has to be interactive. So if there's no noise in your room, just unmute yourself. Have you been able to import the data?
Yes.
Which data?
Yes, sir.
Who adds which data?
Me, Rachel.
But you've never joined this lesson before.
I have. Is
Yes,
it the old one?
yes,
One you
yes, yes,
sent
yes,
us?
yes. The data
Okay.
with the reason.
Okay.
Okay, so today basically I just want us to learn how to use data to do regression and how to interpret the output, because in the exams that is what you need. They just do the regression, they report the output, and be asked to use the output to answer some questions. So after we do that, we'll look at how we do hypothesis testing through the regression model, and we'll also look at the various commands for those individual t-tests. Okay. If you look at our data, please let's browse the data in. So just type browse. It will open the data window, the browse window. So I'm sure you have this on your screen. This is the data set that we have. Okay. If you look at wage is talking about maybe the salaries for a specific number of workers, and then the hours is talking about maybe the number of hours that they work per week. IQ is a person's IQ level, and then this is the level of the person's knowledge, education, experience, tenure, age, married, whether the person is married or not. And then we have black, we have SAT, and then urban. This one is whether the person is living in the south or the person is living in the north. Is the person living in an urban area or the person is living in a rural area? This is about the person's race. Okay, is a person white or is a person? All these ones are called dummy variables. Okay, the ones that have specific assigned values. For these examples, they only have two values. Is either, if you take something like married, is either the value is 1 or the value is 0. Okay, so we call them dummy variables. All these ones are dummy variables. And not just this, it's not always that they just assume two values. It's possible that they can have even up to 4 values. We call them categorical dummies. For example, we have about 1,000 people, and then we are talking about the continent that they come from. It's possible someone comes from Africa, Asia, Europe, America. So we can have from 1 to 4. Okay. So you have to tell Stata what 1 means. Maybe 1 means that the person is coming from Africa. 2 means that the person is coming from Europe. I mean, in that order. So when we use them for the regression, we have a way of interpreting them. Okay, so we'll talk about the dummy variables, and then these ones are just normal variables. So what we want to do here is we all have a fair idea about what regression is. You did it in the stars, and then you've done it in econometrics, at least mechanically. So as for the interpretations, it shouldn't be difficult at all. You know that in any regression model, we have the dependent variable, and then we have the independent variables. Okay. Here we are just looking at just a linear regression model. Okay, I'm sure you were told we have the simple linear regression model where we have 1 dependent variable and then 1 independent variable, or we can have multiple linear regression model where, of course, we have 1 dependent and then we have multiple or more than 1 independent variable. So if we talk about a simple linear regression model, it can be that we want to look at how educational level affects wage. So here, wage is the dependent variable, and then education is the independent. This is just a simple linear regression model. Please, let's take it off. Right? Take the browser off. So now, let's see how we can get a simple regression model where wage is the dependent variable and then education is the independent variable. Or we can even use hours of work. So we want to see how the number of hours that the worker works per week affects the person's wage. Okay, does it mean that when you work for more hours, you have to get a higher wage? Or does it mean that if you rather work for more hours, you get a lower wage? The regression model should be able to tell us that. Okay, so the command for regression is you can use regress or just reg. Okay, you can just use reg or regress, and then the dependent variable comes first. You can choose to type it wage, but if you don't take your time and you misspell it, it won't work. So you can just go to the variable window and then pick wage. Okay, so if you see this backward arrow, if you see the backward arrow, you just point to that arrow, press on it, and then that variable will come to the command window. So we want to regress wage. So regress wage, that is the dependent, and then maybe we are using hours of work as the independent. So we bring hours of work. So now we have reg wage hours. Okay, reg wage hours. This is the command. So just enter. Okay, just enter. Just enter. Okay, please, did you get this? Hello.
Yes, sir, I had it.
Yes, please.
Hello.
Please unmute yourselves.
Yes.
Unmute yourselves.
Yeah, I had it like that.
Right. So this is what we are all to get.
Sir,
Yeah.
sir,
Yes.
sir, please, it didn't come. My own didn't come.
Why? What happened?
They wrote no variables defined.
But have you imported the data?
Yes.
You've imported the data.
Yes.
And-
After I cancelled, after we did
When you
research for
check,
the data,
when you check the
then I cancelled. I
variable
can't find
window,
it.
Kezia, when you check the variable window, do you see your variables there?
Yes.
Just do it again and let's see. Regress wage. Did you type them
Okay.
or you pick them from the variable window?
I typed them.
That's maybe you didn't type something wrong. And so just pick them from the variable window.
Okay.
All right, please, apart from Kezia, do we all have this on our screens?
Yes, please.
All right, so this is just a simple regression model where wage is the dependent and then hours of work is the independent variable. Now, whenever you have a model, the first thing that you'll be asked to do is to write out the model. Okay, you'll be asked to write out the model. Now, the general model that you were taught was y equals beta 0 of this long. Beta 0, then beta 1, x, right? Then we have our
Yes.
error term, okay?
Error term.
Yes. Now, after you've gotten the model, we don't bring the error term again. So if you are asked to report this regression model here, our y, which is the dependent variable, is the wage. That is what you see here. Okay. So you write your wage. So wage equals, then the beta 0 is a constant. This is a constant. Okay. Okay, so the beta 0 is the coefficient for the constant. This is the coefficient. Okay, so you write your coefficient here. Then whatever sign that you see here, if it's minus, then it becomes minus, then 0.5 x. Here our x is what? Hours of work. So we have 0.5 maybe, then hours. Okay. So now, as soon as you take this regression model, you are able to know which one is the dependent variable, which one is the independent. This is the constant, the y-intercept, and then this is the slope of what? Of the model. That's the coefficient of the independent variable. Is that okay? So the betas
Yes.
are the coefficients. The betas are the coefficients, and I'm sure you were taught how to find the standard errors. This second column here reports the standard error, and then the third one talks about the t statistic. I'm sure you remember how to find the t stars. I think it's beta hat over the square root of something, right? So this is how we find it.
Hey, it is
Beta 0 minus beta hat minus the hypothesized value over I think the square root of something.
over the standard error of the
The standard error.
standard error
root
of the
what?
beta.
The standard error is the square root of what? The variance.
of variance. The variance.
Very good. So you see that here you don't need to chew all those formulas. That is why I don't remember them, because I don't need them again. The Stata will do everything. And this is the p-value. Okay, the p-value, we'll talk about it. And then this is the confidence interval. I'm sure you remember in statistics, you can be asked to find the confidence interval of a particular variable. Okay, here you see 5% confidence interval. It means that the level of significance is 5%. Okay, the level of later on, I will show you how you can change it to either 10% or even 1%. Okay, so this is just a simple regression model. Now, this side is the ANOVA. Okay, here, remember stars, you were asked to find regressions, sum of squares, errors, sum of squares, and then totals, sum of squares. That's the breathing. I'm sure you remember.
Yes.
Good. Now we can easily get it from Stata. This column is for the sum of squares. The model sum of squares is what at times we call the regression sum of squares or explained sum of squares, depending on who is teaching you and then the kind of book that person is using. So is either model regression or explained sum of squares. So that is what we have here. And then this is the residual, the error sum of squares. And then the last one is the total sum of squares. You realize that
Okay.
when you add these two, you get the total sum of squares.
Sum of squares.
Yes. Okay, so this is how you get your sum of squares to any regression model. You will see this thing there. Okay, any regression model, you see it there. And then this is for the degrees of freedom. Okay, this is degrees of freedom. I'm sure you've been doing hypothesis testing, right?
Yeah.
Hello.
Yes, sir.
Yeah, you've been doing the hypothesis testing, so you know what the degree of freedom is. I think
Yes.
F is
Yes.
the first one is what is n, and then the other one is n minus 2, right?
N minus 2. Yes.
So, that's what we have here. The n is talking about the number of regresses. This one here, I think one is k minus 1 and n
Minus K.
n minus k. The k is the number of regresses.
Regresses.
So here we have only one. Okay, it's just one. So that's what we have here. Now we'll use the multiple regression model to do the explanation, but I just wanted you to have a fair idea of what the regression is about. When you come to this side too, it's reports one, the number of observations. Okay, so this data has 935 observations. That is what we have.
Observation.
And then the second one is the F statistic. I don't remember the formula, but I remember we can use ESS and RSS to find it. And then I think there's another formula too. That's when you are doing overall.
There's the R squared formula.
Yes, there's an R squared one, and then there's one that we will use ES and then the ESS.
Use the SSR.
So that is the F stars. When you do your mechanics, this is exactly what you get. You see, the issue is that like the examples that you guys use mechanically in econometrics, at times the regressors are just maybe 2 or 4. Even if it's 4, the observations won't be so much. If it's so much, there's no way you can use your mind to do it. So something like this, 935 observations. Assuming you are looking for, I don't know, which formulas are you using? Are you using the lowercase formulas to find the details, or you are using the big matrix form? I don't know if you understand what
it depends on the one that you are comfortable with.
And so you were taught both, eh?
Yes, there's the movement.
X prime, X inverse.
Yes.
Okay. Or you can use the lower case one.
Yes. Or you use the yes.
So it
The
depends
OLS
on
estimator.
it depends on which one that you are using. After you are done. Now, just assuming you have 935 observations. I mean, how do you compute x minus mean for all these observations? It's going to take time. You see why we need the statistical software. So this is your F stars. Then this is called probability greater than F. We use it to measure overall significance. We will talk about it later. So the whole model, is it significant or not? Then remember this guy, R squared, coefficient of determination.
R squared.
Yes, that one
determination
will be reported. And then if you remember, we said that the R squared is prone to increasing your number of regressors. If you have a lot of independent variables, then you realize that R squared will be very large, suggesting that the model is very efficient, which might not be true. So they introduced the adjusted R squared. That one too, there's a formula. 1 minus R squared something. I'm sure you remember that. So that one too, we don't need to use your brains. The Stata will just regress everything. So this is just a simple regression model. Let's look at the more advanced one. So let's regress weight on. Let's take hours. Let's take please, let's take the same variable so that we have the same coefficients. If you use a different one, the things will change. So regress weight on hours. Let's take age, and then let's take married. Okay, so regress wage, hours, age, and married. Regress wage, hours, age, and married. Are we together?
Yes.
All right. So please, let's enter. Please, let's enter. Are we on the same page?
Yes, please.
All right. So first, let's report this model. Okay. If you want to report this, it will be wage equals the constant. So 237.4672 minus 0.95 hours plus 18.7494 age, then 159.1741 marriage. Are we together? If you are asked to report the model, this is the dependent. Wage is the dependent. So wage comes first.
Yes.
Wage comes first. Then you come to the constant. Then you continue with the other independent variables. Okay. Now let's start with the interpretations. Let's take hours of work. The first one we deal with.
Hi, the library.
Are you saying something?
No, I was asking if the library is open.
Now, if you take hours of work, the coefficient is minus, right? If it's minus, it means that there is a negative relationship between hours of work and wage. Okay, there's a negative relationship between hours of work and then wage. What this means is that a worker should increase the number of hours that he works per week by 1. So if you are working hours by 1, then your wage will reduce by 0.95 units. Are we together? We are looking at the interpretations of the coefficients. I'm saying that if you take the coefficient of that independent variable and the sign is negative, it means there's a negative relationship between that variable and the dependent variable. So here the coefficient of hours of work is minus. So it means that there's a negative relationship between hours of work and wage. Simply speaking, it means that when hours of work increases, wage is supposed to what? It's supposed to fall. Are we together? When hours of work goes up, wage is supposed to fall. Yes. If you want to use the value to interpret it, this is how we do the interpretation. If hours of work should increase by 1, or if a worker should increase the number of hours that he works per week by 1 hour, then wage will reduce by the value that you have here. So the value is 0.95. So wage will reduce by 0.95 if hours of work should increase by 1. Are we together? Hello. Now,
yes, please.
Let's take another one. Let's take age. You see that the coefficient of age is positive, right? it means that the older the worker, the higher the worker's wage. There's a positive relationship between the worker's age and the wage. So as you are growing, then your wage too will be what? Will be increasing. That is what the sign means. You having a positive sign. Okay. Now, the real interpretation is that if the worker's age should increase by just 1 year, then wage will increase by 18.7494 units. So if it's in cities, then when your age should, so now you are 24 years. If your age should be 25, then it means that your wage will increase by 18.74 Ghana cedis. Is that okay?
Yes, please.
So that's how we do the interpretation.
Please explain -1.
Which one? The -1.
The negative.
Yeah, the
Yes.
negative means that independent variable moves in opposite direction to the dependent variable. So here is hours of work that has that negative coefficient. So what this means is that if hours of work should increase by 1, then wage would decrease by 0.95. Okay, so if you are a worker and you try to increase the number of hours that you work per week by just 1 hour, your wage will decrease by 0.95. Hello. Hello.
Hello, sir.
Yeah, sorry, my network was messing up.
Yes, please.
I hope you guys can see the screen.
Yes, please, we can see it now.
Yeah, so I was talking about the negative coefficient. What it means is that there's an inverse relationship between hours of work and wage. So if hours of work should increase by 1 unit, then wage will fall. By how many units is this value that we have here? 0.95 units. Is that okay?
Yes, please.
Good. But for this one, remember I told you these ones are called dummy variables. Is either this person is married or not. Okay, is either this person is married or not. Now, what you see here, maybe we told Stata, remember married is either 0 or 1. Okay, so assuming we told Stata that 1 means the person is married, okay, and then 0 means the person is not. So after you run your regression and you get this coefficient, please, this is how we give the interpretation. It's not like these ones where we say that if this one should increase by this and that. If someone is married or not, you can't say that if the person is married should increase by 1 unit or no. It's either the person is married or the person is not married. So if 1 stands for those who are married and 0 stands for those who are not married, then this is how we give the interpretation. Now, the dependent variable here is wage. So what this means is that if the worker is married, you see that the coefficient is positive. So if the worker is married or married workers earn 159.1741 Ghana cedis higher than those who are not married. Married workers will earn 159.1741 Ghana cedis higher than those who are not working. So we have something called the reference dummy. The reference dummy here is 0. So we'll compare those who are married to those who are not what? Those who are not married. Here we don't talk about increase or decrease. It cannot increase, it cannot decrease. So if 1 is for those who are married, then it means that if the person is a worker and the person is married, like if you take 2 people, one person is married and the other person is not. The person who is married will earn 159.1741 higher than the person who is not married. Now, when they report this in the exams, okay, they will put something in the bracket. So maybe they will write married, then into bracket 1 will be equal to married, then 0 will be equal to non-married, so that you know that 1 is standing for someone who is married and then 0 is standing for someone who is not. So always use the 1. Okay, so here 1 is for those who are married and the coefficient is positive. So those who are married will earn 159 Ghana cedis more than those who are not. If we have to change this and make 0 those who are not married, and 0 those who are married, and 1 be those who are not married, then the sign here is going to be negative. So the explanation will be that those who are not married will earn 159 Ghana cedis less than those who are married. The intuition will be the same thing.